Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Now we'll work on problem 110 from chapter 21. In this problem, we're told that nitromethane has the formula CH3NO2 with the N bonded to carbon and without OO bonds. So we need to draw its two most important contributing structure, then answer a few questions. So let's go ahead and draw the structures for nitromethane. So there's two structures, we're told. So first is we have a CH3, and then we have an N, we have a double bond to O and a single bond like this, and this would have a positive charge. And then the second structure will simply flip the double bond. Like this, so two structures. So the first question that we're asked is, what is the hybridization of the carbon, and how many hybrid orbitals are in the molecule? So first, let's talk about the carbon hybridization. Here, this carbon here is bonded to 4 atoms, so the carbon atom has sp3 hybridization. Now, next we're asked about how many other hybrid atoms, so orbitals. So we have nitrogen will have hybrid orbitals. And it's bonded to 3 atoms, so it will be sp2. Then also we have a single bonded oxygen, which is only bound to one molecule, one atom, but if we were to draw in the lone pairs, we would see that there's 4 areas of electron density, so it's also sp3 hybridized. And then finally, we have a double bonded atom, oxygen. And if we drew in the double bonds here, we'll see that we have 3 areas, so it's also sp2. So the next question that we're asked is, what is the shortest bond? So let's draw that here. And the answer would be the double bond. Because double bonds are shorter than single bonds. Now let's go ahead and open a new page. Let's answer question C, which is which bond is the strongest. And so this is also the double bond because 2 pairs of electrons are shared versus 1. Now the third question asks us, will the HCH bond angle be greater or less than 109.5? So let's go ahead and redraw one of the structures here to show best. So we get nitrogen. So here we have normally on an sp3 carbon, this angle here would be 109.5 in a tetrahedral arrangement. However, we don't have another hydrogen normal group over here. So we have an NO2 group, which is very bulky. So it pushes the hydrogens away from itself. So that means that the hydrogens would be moved close to each other, and the HCH bond angle would be less than 109.5 degrees. And this is because NO2 is bulkier than hydrogen or any other normal substituent that would be there.